Okay guys, we're going to be finishing up this review in class tomorrow. So I want to go over a few of these problems just to make sure you're on the right track. Let's go ahead and start off with number 2. First of all, number 2 has a vertical translation of 3 units. So we would go up 1, 2, 3 units up. This is our K value. Remember, our parameter changes. A is our vertical stretch or vertical compression. Inside the grouping symbol, we have our horizontal. And remember that this is always the opposite. So if it's plus, it's to the left. If it's minus, it's to the right. And then K is our vertical translation. And it is what it is. If it's plus, it's up. If it's minus, it's down. So again, we went 3 units up. The negative means we have a reflection. We have a reflection. Remember what the parent looks like. The parent looks like this. It starts at 0, 0. And we will go over 1. The square root of 1 is 1. We go over 1, 2, 3, 4. The square root of 4 is 2. 5, 6, 7, 8, 9. The square root of 9 is 3. And that's how we get our square root function. That's our parent. Okay? Well, here it says to make all my x values negative. Well, notice that all my x values here are positive. I want to make them negative. Well, if I go over the x-axis, will my x values become negative? No, because x is positive over here. So whether you're above or below, you still have positive x values. So let's go over the y-axis. Now, if the x values are positive here, what's going to be on this side? Negative. X values are negative here. X values are positive here. So we're going to go this direction. Okay? We use the same technique for graphing. Okay? We go over 1. Square root of 1 is 1. Go over 1, 2, 3, 4. Square root of 4 is 2. 5, 6, 7, 8, 9. Square root of 9 is 3. So we graph the equation. It says describe how this graph is different from the parent. Okay? Sorry, I missed my points here, but you get the idea. It should be like that. So describe. Well, we have a translation. Three units up. Notice the special point moved up 1, 2, 3. Okay? The second thing we have here, we have a reflection over the y-axis. So the parent got flipped over the y-axis. Okay? It says then state the domain and range. Alright, so the domain and range, I'll go ahead and go down here. I should have put my description down here. Domain. So the domain values, personally, you can do it one of 2 ways. You can do it the old-fashioned way, where you put the O less than, X, and less than, and we go from left to right. So on the left, we have an arrow. So we're going to negative infinity on the left, and on the right, we're at 0. And that's a closed dot. Okay? Or you could just say that x is less than or equal to 0. Either way, whichever one makes the most sense to you. Okay, range. Remember, range is lowest to highest, so the lowest point is 3 on the y-axis. It's a closed dot, so I'm going to put an equal sign in. And the highest is an arrow, so an infinity symbol. Or you could say y is greater than or equal to 3. Okay? Let's turn it over on the back. And let's go ahead and go down here. Remember, on this one, you're going to need to plug this into your calculator, into stat edit. Do not forget to include this point. A lot of people forgot to include that point. Turn your stat plot on, set up your window, graph it, and then try to figure out an equation to model this. Now remember, you're trying to figure out an A value. Okay, why not an H? Why not a K? Well, H and K are 0 and 0. That's our special point. That's our starting point. So we're just looking for an A value that will connect all these points, or as many of them as we can. Then we use this equation to answer these two questions. Let's take a look at number 12. Okay, so we want to solve. So since this is multiplication, we would go ahead and divide. And the reason why I'm going to go ahead and divide here is because I can divide by 4, and I can divide by 4 on both sides. So I'm going to go ahead and do that. So I'm going to end up with the square root of x equals 3. Okay, now we can get rid of the radical, square both sides, we get x equals 9. Remember to check your work. Never know when you might have an extraneous solution. So let's plug it in. The square root of 9 is 3. 3 times 4 is 12. It checks out. Okay, let's take a look at number 16. Number 16. Well, the radical is by itself, so I'm going to go ahead and square it. So I'm going to square both sides. This is a group. Remember, the minus makes it a group, so I'm going to put a grouping symbol on it, because I'm going to take this group here and I'm going to square it. Anytime you do something to a group, you want to put the grouping symbol on it and then do whatever it is you want to do to it. So we're going to have 4 minus x times 4 minus x equals x minus 2. We're going to FOIL it, so we're going to do first term, so 4 times 4. Outer term, so 4 times negative x. Inner terms. And last terms. Okay, now we notice that it is quadratic, so we have to set the equation equal to 0. So I'm going to go ahead and set this side equal to 0 by subtracting x. That's going to cancel that x out. I'm going to add 2. So that's going to cancel that out. Okay, so we end up with, I'm going to rewrite this. I'm going to start off here by writing x squared. Combine like terms. So that's going to give me negative 9x plus 18. And that's all going to be equal to 0. Okay, I'm going to go ahead and factor this. Go ahead and use the x factor if you need to. So 18 times 1 on top, negative 9 on the bottom. I think two numbers that multiply to give me 18 and add to give me negative 9. It's going to be negative 6 and negative 3. So the a value goes on top, the factor goes on the bottom, the a value goes on top, the factor goes on the bottom. So we have x minus 6, x minus 3. Okay, remember we're solving, so we're trying to get x by itself. So we got to set each factor equal to 0. So x minus 6 equals 0, x minus 3 equals 0, x equals 6, x equals 3. Now, before we say yay, we need to check our answer. So let's try 6. So 4 minus 6, negative 2. 6 minus 2 is 4. The square root of 4 is 2. They do not equal, so this is extraneous. That's an extraneous solution, an extra solution. Let's try 3. 4 minus 3 is 1. Let's see, 3 minus 2 is 1. The square root of 1 is 1. And that works. So x equals 3. All right, let's go down here. It says, for each equation below, state the type, then graph both the given function and its inverse. Finally, state the function type of the inverse and write the equations of the inverse. Okay, take it one step at a time. It says, for each equation below, state the type. Okay, which one do we want to do? Let's just do this one, okay? This is quadratic because of the square. Okay? It says graph both the given function and its inverse. Okay, so let's graph the given function. This says to move the function 3 units to the left. So I'm going to go to my special point, and I'm going to go 3 units to the left. 1, 2, 3. So since it's quadratic, we'll call that special point the vertex. Now, remember the a value here is 1, so we're going to go over 1 and up 1. We're going to go over 1 and up 1. And that's going to give us enough points to make our quadratic. Now, it doesn't say it here, but it's very helpful to put in our line of symmetry when doing inverse. Now, I have less than a minute left. So when this runs out, it runs out, okay? Time will run out. Now, to get the inverse function, remember we switch the x and the y. So this is negative 3, 0. So we're going to use 0, negative 3. This one's negative 2, 1. So we're going to do 1, negative 2. And then the other one will end up here. Now I know we're running out of time, so I'll see you guys tomorrow. to finish